Hello, everyone. Good morning, and good morning, at least from the US. And thank you for joining us today. This presentation is going to be on finding anti-patterns in T-SQL scripts using a tool that has been around for a long time, but not heard of or used very much, which is ScriptDOM. This is a little bit about me. My name is Mala. I've been part of this community for a very long time, since 1999 almost. I've worked with SQL Server for more than 20 years. I am a co-lead on two user groups, the Data Platform Women in Tech user group and the Triangle Area SQL Server user group. I am also a book author and I have a blog. And the easiest way to reach me is on Twitter at SQLMAL. Koen?
All right, welcome everyone. My name is Koen Verbeek, senior BI consultant working at a company called AE in Belgium. I have my own blog at sqlcover.com. I have Twitter as well, so we can always ask questions on Twitter if you like to. I write a lot of articles on mssqltips.com, mainly about the Microsoft Data Platform. And I'm from Belgium, so this means I like beer, I like fries, and I like chocolate as well. All right, back to you, Mala.
So today's presentation, I have a bit to cover. I'll be talking about what is understanding what is ScriptDOM, why do we think it is useful, because this is not anything new, it's not anything external to SQL Server, it's been part of the product for a very long time, just not known very well. We'll also look at how to create some PowerShell scripts using this tool that can identify some things in your code. We'll look at how we can fix some of these things. We cannot fix everything that we find. We can definitely fix some of it. And we'll learn the pros and cons of using this tool as well. So to get started, Koen will explain why he's here.
Yeah, so I'm a BI developer, so I don't have lots of PowerShell knowledge or even knowledge about CI, CD, DevOps, stuff like that. So yeah, we kind of throw stuff into production and quality of the code is bad and we want to fix that, right? So we don't want our ETL failing or behaving like imperformant because people are writing select star or using nolog everywhere. So we need to do some review on that code basis, but it's a very large code base, so we cannot manually review all of the SQL code that has been written. So we need something that automates this process. So when someone checks in code or something like that, some sort of process runs and does automatically some checks on the quality of this code. So sort of these anti-patterns that Mala will talk about. So we don't have the time to do it ourselves, so we need some automated process. And this is the focus of our meeting here today. So Mala is going to explain to me what tool we can use to automate this kind of quality code checks. All right, that's my dilemma.
So to get started, what exactly are anti-patterns? Anti-patterns are essentially things that we put into code that is intended to solve a problem. But over time, it tends to lead to various other problems. Anti-patterns are practiced pretty frequently. They're very widely in use and they have their place. They have some legitimate uses. A classic example of an anti-pattern is a select star. Select star, the intention is for you to have ease of coding is if you have a table with a lot of columns, then an easy way to pull everything out of it is to use the star. Does it have legitimate uses? Yes, absolutely. If you use a select star in an if exists clause, or if you are just using it to pull everything out of a temp table that you're not going to be changing any schema on or anything like that, yeah, it does not cause any problems. Problems happen when you start to use it everywhere. And that's kind of the definition of an anti-pattern. And in the T-SQL world, we have a lot of anti-patterns. Some of the examples are, I have listed those. The purpose of this tool essentially, like what Koen said, is if he had a large code base, then how is he going to go around finding all this? Am I right, Koen? That's the dilemma, right? We have so many conditions like this. and it's difficult for somebody to go and find all of them. So based on what he said, I came up with a few options. One is the text-based search, 2 is using a regex, 3 is third-party tools, and the last one is ScriptDOM. And let's look at the pros and cons of each of these. So for each approach, the text-based search, this is widely used. We use it almost every day. The problem with the text-based search is that it's going to grab every instance of what it finds. So if you're searching for a no-lock, it's going to find a no-lock that's in a comment. It's going to find a no-lock that's in a section of code that's been commented out, all sorts of things, or even, something that matches the verbiage no-lock that's buried in some text. So a lot of false positives and incomplete details. That is where exactly it resides in the code. That's hard to find when you use a text-based search. Regex. Regex is complex to construct. I don't know about the people listening, but I have never had writing a regex query, no matter how, for every situation that's even a little bit different, you need to alter the construct. So that is the problem, is that it's just way too much effort. Third-party tools, there are a lot of third-party tools that can do linting for you. But the problem with them is that most of those tools are written for the specific needs of whoever wrote them. They may not match what you need by way of your naming standards or what your particular organization thinks is appropriate as an anti-pattern and that kind of a thing. So they need a lot of upkeep. And what about DMVs? You can definitely use DMVs to find patterns. DMVs have in some ways the same problems as text. When you use them to search stored procedures, all they do behind the scenes is do a text search. And DMVs, they can only find issues after an object is created. So like Kohn explained in his situation, what if I want to make sure my code is clean before it actually goes in and creates the object, not after? So there, chances of you using a DMV is pretty hard in that kind of a scenario. So these are the problems with each of these approaches. And that is when I narrowed into ScriptDOM as something that I want to use. The main advantage of this thing is to find problems before objects are created, not after. And it's a totally scientific method. It's not going to give you false positives like your text search did. And what is really cool about it is that there is a different version for each version of SQL Server that you have. For each compat level on your database, it goes back all the way to SQL 2008. Sorry if you have SQL Server versions that are even older, it may not, but that's reasonable. It goes all the way back to that, and it can do whatever it does for the specific version that you're going to be using. So for all these reasons, this is pretty cool, right, Kohn? That you have so many things that you can use.
Yeah, that's true. Yeah, I definitely cannot write regex expressions. So yeah, the ScriptDOM seems very promising.
So let's go into what this is. ScriptDOM is essentially short for T-SQL script object model or a script document object model. And it is part of the .NET Framework library. Currently it used to be part of the .NET Framework library, but .NET Framework, but now it is of the DACFX package. So if you download the DACFX package, this library as part of it. It is just one library, one DLL. What can it do? It can do a whole bunch of different things. It can parse T-SQL scripts and find any errors that you have. And then it can do formatting of it. If your scripts are misaligned, it can format the scripts and neatly align them. It can find anti-patterns, which is the main use, like we saw in the beginning. And it can also help you fix some of those anti-patterns, which is a good list of things, I think, that are bundled into one tool in of itself. So to summarize, when it is most useful, before we get into actually seeing how it works, it is most useful when you have a really large code base. Now, when I pointed out the differences between using text searches and DMVs and all that, all those things have their place. And on an everyday basis, when you have a small code base, you're probably better off using those things. This is intended more for a large T-SQL code base. You have a lot of legacy code, and you want to find issues mostly before they get deployed, not after. And you don't want any stress on the servers while you're finding them. Like you run a big DMV query trying to find a no lock in a bunch of stored procedures and such. You don't want to stress your server because it's already, handling a bunch of other stuff. So asynchronously looking for these problems. That is when these are the under which ScriptDOM has the most use. So let's get into how we can get there. Installing ScriptDOM is really easy to do. The Microsoft link for the SQL package will help you download and install it. There is a separate version for .NET Core and .NET Framework. The examples that I'm going to be using are the latter. And all you need is that one DLL that is there. Depending on which version of SQL Server you have, this path may be slightly different, 150 or whatever the number may be, but that is where it puts it by default. You can copy it from there into wherever you want and run the scripts from there. It will work just as well. And this one DLL is all that it needs. So there is no SQL Server install necessary for any of this. Let's look at the basic structure of the library. This is the namespace. This namespace is like really, really big, well over 1,000 classes. It has a class for every T-SQL construct there is. So it's pretty large and it keeps getting larger as T-SQL continues to evolve. The important classes, the main class, that's the backbone of this, is the Parser class. And it has a different one for each version of SQL Server. As you can see, 170 all the way back to 80. Depending on what your compat level is, you can choose what that is. T-SQL fragment, which is actually an abstract class, and it's a pair for several other classes like you can see. And the third one is T-SQL fragment visitor, which is the visitor pattern implementation. And I will explain what that is. This is what we are going to be using to find anti-patterns. And the script generator is what we use to format the scripts as well as fix some of the problems we find. So these are the main classes, important classes that you need to be aware of. In addition to that, there are a lot of individual language. Each in the language has its own class. Some examples I've put out here: name, table, reference, select, star, expression, and so on. So that's the basic structure of the library. It's not all that hard to learn. Although if you're like me, you're coming from the transactional DBA world and you're intimidated by a lot of programming terms, then you may find it a little bit hard initially. But once you get the hang of it, it's actually pretty easy. So let's start with seeing how the parser works. The parser actually, it consists of two parts. One is the lexer, that is, it creates tokens from the script that you pass to it. And the second one is the actual parser, which matches these tokens to the syntactical or the grammatical rules. Now, I'll just show you real quickly how this works. Can you see my demo?
Yes.
Go on.
Yes, I see you.
Okay, so this is how you parse a script. I'm going to walk through the script real quick before I show you how it works. So this is a simple script I pulled from AdventureWorks. And what I have here, so many lines. Oh, goodness. So what you essentially have to do is to add a type reference to the DLL that I just showed you, and then create an instance of the parser, which, like I told you, there are different versions for each compat level that you have, and mine is 150, so I choose the 150 parser. You can choose whatever you like. Then you create an error object that's going to hold the errors if there are any errors. And then this is the string reader that's going to parse the script that you send. That is going to take the script that you send and create like lines out of it that is going to be input to the parser. And once the parser gets it, if it finds any errors, it's going to put it into the error object. Otherwise, it's going to tell you that it all looks clean. So this is what I'm going to do. I run it. So there are no parsing errors in the script that I have. If I introduce something, just to show for the sake of the demo. Let's say I'm going to do, I missed an E there. So it's going to tell you right away that it doesn't like what it finds near the set. That's how it works. And I fix it, and run it, and it's all good. So
it seems these are like the very same things you see in Management Studio.
Yeah, it is. I'm not sure if they use ScriptDOM inside of Management Studio, but it's, functionality wise, it's exactly the same thing. The only thing to be aware of here, it's just 4 lines of code to just make sure that your script is syntactically right. So the important thing to be aware of here is that it can only check your syntax. It cannot validate your schema. So if you have a field name that is wrong or a table that is missing or something like that, because it's not connected to any SQL server, find stuff like that. But it can verify if your script is syntactically right. So that's what it does. And the output that it creates here, this past objects, this output, this is what holds the abstract syntax tree that we're going to see. And that's what we're going to be using to find the anti-patterns. Okay, going back to the presentation. Okay, so we saw how the parser worked, and then the next thing that we want to see is to use it as a formatter. The formatter is, I'm just trying to cover some of the non-critical functionality that this has before we get into actually finding, seeing how the rules work. So the second part of it after the parser is how you can use it as a formatter, that is to make sure that your code is clean and formatted right. So the formatter works like this. Let me walk you through the code before we see how it is. So it's the same thing as what we saw before, and you create, instead of you go up. So input script where the input script is what you want to format and the output script is what is create. So you can look at it, and then you have a bunch of different options that align various things up and down, that kind of stuff. And then these things are all simple standard formatting options that everybody has, so it's not that hard, and you're better off setting all of it to true for the most part. But like anything, you can also set it to false if you like, and then you create an instance of the generate object, the script generator. You pass the same thing and that we saw with the parsing script, and then convert it and then give you the output. That's how it works. So I'm going to show you here a script that I have that is not very well formatted. So I can see, you can see here that I have, the select thing is not aligned and it looks kind of messy and difficult to read. So I'm going to try and format this using the script. So you can scroll up here. It has created an output also. You can see that here too. If I open this, this is the output it created. See, it's neatly aligned everything for us. Or maybe you can look at a compare of both. You can see that too. That is the one to the left is the one that's been formatted. You can see that it's neatly aligned everything based on what, the preferences that we set. So that's kind of how it works. It's really simple to use. The only hassle with this formatter though is that it's going to strip your code of comments, because that's essentially how formatters work. So if you want Microsoft to fix that issue, I have a GitHub link on my presentation. I've opened it with them. Please go and upload it. It can be very useful in many situations if they go and fix the fact that it cannot retain comments as of now. I won't talk too much on this because that's not the focus of the talk, but it's really important that we use it, use it and keep the comments, because most people want their comments in place. But currently, the problem it has is that it strips the code of comments. Okay, let's get back to understanding more of how what the output that it creates and how we can use it to fix some of the anti-patterns. So the output that it creates from the parser is essentially called an abstract syntax tree. An abstract syntax tree, essentially, it's a tree representation of the syntax. That is, each node of the tree denotes a construct occurring in the text. So what a DOM does is to take your scripts and make a tree out of it. And that representation is called an abstract syntax tree. And this is the output of the parser. Let me show you how this looks. Does that make a bit of sense, Kon?
Yeah, it definitely makes sense. I see there's a question from the audience. Someone asks if the code examples will be shared.
Yes.
Okay, yes. And where can they find them?
It's part of my GitHub link. It's part of the presentation.
Okay, great.
If you download the presentation, the link is there. Okay. And I don't know if Bits has another way of putting it. I'll also, if I have time, I'll also share the link in the chat when I can.
Okay, great.
So this is a simple select statement. I'm going to show you how the abstract syntax tree it creates works. So all I have here is the select statement. And then the output is the passed objects. And then I'm going to be, before I walk you through the rest of it, I'm just going to, so my goal here is to find some no-lock hints that are part of my select statement. This needs to run first. So it found my no lock. So how it found it, let's look at this. So this passed objects, this is what I call the abstract syntax tree that ScriptDOM creates to find what I ask it to find. So I can go down and, browsing this manually like this, like exploring the content. There are a lot of arrays. So you can see that the first statement is the select statement that we had. And then I go down a little further. So you can see all that the select statement has, it has made a tree out of it. So the first one is the query expression. And then all the different parts of the select statement, that is an into, an on, the compute class. If you have a CTE, you can have a CTE there. You can have all this. And this last part that you see is the script token stream. This is part of the tree at every level. And I'll explain what that is in a second. But what you find patterns, actually, one way of finding these patterns is by going down this tree like this. So if you go down this query expression, you can see that's the where class. And then you go, you keep digging deeper and deeper and deeper. You can see how deep it is for just one select statement. So you go down here and, you keep going like this. And that's essentially what I have done here programmatically. And then when I hit something that looks like the no lock, I look at the statement type, and then I look at the table references, and the way the table structured is like one table is chained to another and the chain to the fourth and so on. So you need a recursive query to find those. And once it finds the table, then it can find the link, the hint in that table. And then you can see, how you get the no lock. So it's pretty deep involved programming to find something this simple. And this is just one select statement. So if you have a stored procedure with a lot of no locks, and you can imagine the amount of programming it's going to take to find everything like this. You can do it. You can absolutely do it, but it is a lot of code. So ScriptDOM offers an efficient way of doing the same thing, which is by using what is called a visitor class. So let's go and look at what that is. So before we go into the visitor class, why do we need this abstract syntax tree? So this is a common example of a statement like a panda eats, shoots, and leaves. And the statement in of itself, it makes sense. But if you have the Oxford comma there that separates the verbs, you can see it in a completely different light. So this is the purpose of the tree, is to put the right parts of the syntax in the right place so that you can find it as opposed to a text-based search, which will randomly find something, wherever it sees an occurrence. So adding the important context, that's what the abstract syntax tree does, and that's why we need it. So we just saw how the basic structure of how it created, and what I want to show you before we go into this really quickly is tokens and how they work. So every level of the tree has what is called tokens. And what is tokens essentially is that every element of the script is converted into what is called a T-SQL parser token, including the white spaces. So if you have here, I have a really simple four-line script, and I'm going to see what are the tokens that DOM creates out of this. So if you do that, you can see here is that there are three parts to each token. One is the token type, token text, and the third part, the really cool one, is it can tell you whether that token is a keyword or not. So you can see here the word select, it's a reserved word, it is true. White space, it's not a reserved word. So like this, it kind of parses a script into elements that you can use. And this is a sort of a text search if you want to think of it that way. So if you want to find
20 minutes left.
Oh, wow.
That was Ben talking, saying we have like 20 minutes.
So if you want to find things like reserved words that are not capitalized, or some weird thing like people using a join word instead of specifying what kind of a join it is and such, this token stream can be very useful in situations like that. So it is there at every level of the tree with exactly the same elements. The values are different, of course, depending on what branch of the tree you are on, but it's available at every level. So going back to the presentation.
All right, so there's another question from the audience saying, can we enforce code style guides using the library? So like, can they give a JSON configuration as input and then do some checks to force some sort of code style? And I guess with code style, I mean formatting, or just don't use this kind of anti-pattern. I don't know.
Yeah, it depends on what they mean by code style. So we saw the long-winded way of finding what we want to find, like the no-log. So we have to look at a more efficient way of doing this, which is essentially what is called as a visitor class. Visitor class is a programming pattern. I can explain it using an example. So suppose you want to find all instances of select star manually. You can use this example of a person picking apples from a tree. You would have to look at every branch of the tree and pick, and chances that you're going to miss a few branches up. Now, the second way you can do it is the way I showed you, using going abstract syntax tree at every level. That would be somewhat akin to this, like using a tool like this person as shake a branch, but he has a tool, but he still has to go to every branch to find it. And chances that you may miss part of the code are again pretty high, and it can get pretty laborious and labor intensive. The third method, which is the visitor class, is a sort of a backdoor way of finding the same thing. And it's sort of like this tool where it shakes the tree and, it'll drop. So chances that you will miss them, unless you make a mistake in programming, this may miss a few apples, but a visitor class, unless you may make a programming, it's not going to miss finding anything. So let's look at an example of how this works. So this is an example of finding a no-log hint with pattern. So what do I do is pass a T-SQL, the output of the parser, to my code, and then I create what is called a visit. That is an instance of the visitor class, and I tell it what to find. In my case, because I'm looking for a no-log, I ask it to find table hint. So like I initially said, with the ScriptDOM classes, there is a class for every T-SQL construct. So if you want to find something else, it will have something else. And I have a few examples. In our case, we are looking at a table hint. So, and then you look at if the table hint is equal to no-log, then it can easily tell you that it found a no-log in the code. So you have to create an instance of this class that you've defined there. And you have to use what is called the accept method for this class. and you have to invoke the accept method from this fragment that comes into this and pass it this instance of this class, and then it will go there, and once if it hits a table hint there, it's going to tell you, hey, I found a table hint. So it's really scientific and really easy. So let's look at how this works.
Right, just to circle back at the question earlier. So they asked, can you, for example, force a specific way to create an index?
Force a specific way to create an index,
like
or have specific...
It needs to contain fill factor or something like that? Or...
Yes, you can do that.
Okay.
So if a person creates it, if you want a fill factor of, let's say, 90, and the person habitually creates something with a fill factor of 100 or something else, then you can use this to find that problem. You can also use it to fix it.
Okay.
Yeah. So I'm going to use what I saw, the visitor pattern, to do, find no logs, find example.
Oh. It's always with a live demo and stuff like this happens.
Yeah, I hate it. I checked it this morning.
And you have 15 minutes.
Okay. Oof, thank you.
Right, Ben says we still have like 15 minutes left.
Yeah.
So yeah, if we don't find the error, I think we just go to the next part of the presentation.
I'm going to look for it one more time. I had it all working. Okay, I'll get back to the presentation.
It happens sometimes.
Yeah, sorry. So the visitor class essentially has two parts to it: the T-SQL fragment visitor and T-SQL concrete fragment visitor. Both of them are derived classes, not abstract classes. So it's important to remember that. And every T-SQL element is derived from one of these two. And what we saw there, the no log of them, basically the visit method tells you what to do when you encounter a type of class. So using ScriptDOM to fix what it finds, this what the person who asked, it alludes to that. It can fix whatever code it finds. Like an example is if you want an index set wanted to work a certain way, the person has not put the settings in there as it is your standard, then you can use it to find that problem. You can also use it to fix what it finds in that regard. So
right. I don't think we should spend too much time on this demo. We only have like 10 minutes left.
Okay. I'm going to give it one more minute to go,
okay.
because it's an important part of that. Oh, there it is. I found it, so I can get it to work. It's just that Visual Studio Code tends to add spaces sometimes, and I don't know how to fix that problem. So find no lock hint. So see, the example of the visitor class that I showed, the code that we are passing, essentially, it has a bunch of no lock hints, and we use the same thing to find before manually going through the tree, but this is a much more shorter, more efficient code that can do the same thing. So I'll show you a few more examples like this. This one is for finding a 4-part name that is a linked server reference. All know that, that linked servers are dated and we need to get rid of them, but we need to find references to them in all our code. That can be pretty hard to do. So what this does is to find 4-part references in the code. This example, again, we have a few, so it's going to do the same thing. If you run it, it's that it found a table with the linked server, my server on it. And if you go up there, you can see that's going to be part of on line 34. So here I have a 4-part name, and this is what it found. So another example we can look at is finding select star. This is something that, like I said before, it's an anti-pattern that is very common, and we want to find uses of it. So we can go back here, and there are some references to select star in this query. So it's going to find the select star that it found on line 55. See here, there is a select star, and this is what it found. So this one, and this is where you have good use for the tokens, is you find reserved words that are not uppercase. And people have code, this is a very common coding standard, is to have reserved words that are not like this. So again, if you run it, okay. So I can go on. There are a few examples of things that you can find, and let's look at one or two of how these problems. And then Koen has to show you how you can integrate this with your as a DevOps.
Yeah, we have like 10 minutes left. So.
Okay, I'll show one example of how you can fix the no lock hint, and then we'll hand it over to Koen to show his part of the stuff. So the same no lock hint that it found, it's going to remove the references of that from the code. So it spit out an output without the no lock that you had. And to give you a quick overview of how you can do this, basically, you can go here and you have to work a little bit with the abstract syntax tree to understand. What you do is that you go to that branch where the no lock is referenced and you say, remove that hint. So, and then you have to regenerate it using the generator method, and then the output that it gives you will be free of no locks. So that's how it works. And that's how you fix some of the other things too, like the person was asking about fill factor or whatever else issue that you have, is to work through the tree, find where it's referenced, and then remove it. Some of the pros and cons of fixing is that it's not terribly easy to do. It's very scientific, and it's really short code if you understand how it works. Some of the cons are that it will reformat your code. So if you don't like how it formats your code, then you may not be able to use it to fix it. And it will remove comment. This is not an issue when you have table scripts or index scripts or things like that. It can be an issue with stored procedures and such. So it takes a bit of time sometimes to figure out what it has to fix. So let's hand it over to.
Right, so let's pretend we're now 2 weeks later. So I watched the presentation and demos that Mala gave. I was very intrigued by it. So I took the code, the scripts from Mala, and I implemented them in an Azure DevOps build pipeline. So if you can just go to the next slide, please. So I needed to write a little wrapper in PowerShell but it's not that hard. Even I could do it. So, and I'm definitely not a PowerShell developer. So you're reading a folder, which is like the default working directory of your repository in Azure DevOps. And then I added into the repository all of the scripts, all the PowerShell scripts from Mala. So I put them in a unit tests folder. You can see the 4 PowerShell scripts over there. And I also added the actual DLL of ScriptDOM into the repository as well. Because, yeah, if you have a build agent, it's not there by default. So you need to add it and reference it as well. So I just added it in the repo and referenced it directly in my PowerShell script. It was the easiest way. And then just, okay, give me all of the child items of my current folder and only include those that are ending with .SQL. And I just loop over them and then run the scripts to check for all of the errors. Right, so we can just go to through the animations now. So first we check the working directory. You can go to the next.
Next slide.
Yeah, so you can just go to the next slide, yeah. So I point to the repo, and then you reference the DLL. Just keep on clicking till I say stop. So, right, and then you just loop over all of the files that you can find into the repo. All right, so if you go to the next slide, you can see, okay, this is the YAML file. So when you create a build pipeline, it will create a YAML file for you, and you just need to add a PowerShell task. That's the only thing you need to do. You add one PowerShell task, you reference that single file that I gave on the previous slide. I also wrote a blog post in it on my blog, so you can find the code for the wrapper and the YAML file over there. And then if you go to the next, and so the build pipeline will actually still run, and you will get an email saying, okay, it has run successfully. So if you want it to actually give an error or a warning or actually fail, then you need to make some changes to the script, right? So if you go to the next slide. So for example, if you go, just add one animation, please. So if you want to write a warning, then just do write host and then use like the VSO, Visual Studio Online, I suppose. And you say, okay, this is a type of warning, and then just add the kind of warning that you want for your build pipeline. The problem is it's just a warning. You don't actually see it in the email. You have to go to the actual output of the PowerShell of the build. And then, okay, you can see, okay, there's a warning. And you'll get a little warning icon in the email as well. So if you want, especially like explicitly error it out, so that the email says, okay, there's an error, do something. Then you also do the same thing. You log an issue, but now type error. And then you can say, okay, this is the error message you want to give. So in this case, I'm checking for no lock. And I say, okay, if I found a no lock, I'm going to display this type of error. Okay. So you can just click one more time for the animation and just one more time. All right, so the build will still succeed. All right, so PowerShell will give errors and warnings, but the build will still continue running. And if you actually want the build to fail, so that people cannot check in code at all into the repository, then you just add exit 1. Exit 1 will just crash PowerShell, the build will fail, and their code will not make it onto the build server. And then you force the people to say, okay, the build has failed. Take a look at your code. These are the errors. These are the warnings. And then they can check, oh, there was a no lock, and they have to remove it. So they cannot check in their code unless they remove it. So I'm kind of the old school, like, fix your code. We're not going to fix it for you. So you'll learn from your mistakes. All right. So it was actually very easy. Just take the scripts, you put them in a folder, you add the DLL as well. You add a little wrapper around it, just a couple of lines of PowerShell. And then we're done. And then it will check for all those kind of anti-patterns in your code. You can make the build fail if you want to. All right, so I was very pleased with the result. Back to you.
Thank you. So the pros and cons, some of the things, and pros are mostly that because it's a very authentic scientific method, it's really easy. Once, like Koen said, once you figure things out, the scripts are really small and efficient, based on what you want to find, and they're easy to deploy and maintain. It's totally backward compatible with any version of SQL Server, and there is a new version for anything going forward. It's not connected to any active install of SQL Server, so there is no overhead on anything that you have. And best what worked for me in my workplace is that I get to define my own roles and I don't have to depend on any other outside product to do that for me. So essentially, the way this kind of works is only by loading the script entirely into memory. So most T-SQL scripts are not all that big, but if you have a scenario where you have a humongous script, then your memory footprint can be large. So it's approximately 2 gigabytes of address space for a 15 megabyte script, which is a pretty enormous script. So that can be a problem. The second one is that the parser is single threaded. So if you have some, problems with performance on the machine that it's running, then you may have to look into other clever methods for running it on multiple threads. By nature, it comes, single threaded. It definitely needs some programming knowledge, especially for finding nuanced situations where it's more than one visitor class and combine the output of one into another. And a classic example of this, like I have, is it's easy to remove no logs, but what if you have set isolation level uncommitted, which is also a way many people use to enforce no log. What if you want to remove that statement? Then you have to write, you can absolutely do it, but you have to write more code to do it. So that sort of scenario.
1 more minute. So
yes.
I think we need to wrap up.
And that's pretty much it. So as long as you can live with all this, it's an excellent piece of engineering and it is totally worth your effort to learn and maintain your own code. These are some of the useful links that we have. I've included Cohn's link and my own GitHub repo where you can see the scripts we had today. That's also here. I'll try to post it in the chat as well. Thank you. And this is the feedback. Feedback for bits, really important. Please take time to give us feedback.
Yeah, we cannot stress enough how important it is to give feedback. So we as speakers can learn from the experience and how we can improve the presentation and the demos and stuff like that. And of course, make a better event next time. An even better event, sorry. So I would like to thank you, Mala, for enlightening me in the worlds of ScriptDOM and how I can pester other developers so to make sure they don't use select star or no luck in their SQL code.